4/5 was one of the ratios of this triangle, and there should be 6 of them total. So let's shout out the rest of them. What are the other ones? 3/4. Good. 3/4. What's the next one? 3/5. Give me another one. 5/3. Give me another one. 5/4. And lastly, 4/3. Okay. Do you realize that all of those ratios are all of the 6 trig functions? There's a sine in there, there's a cosine in there, there's a secant in there, there's a tangent in there, there's a cotangent in there, and there's whichever one I missed, cosine I think it was. Right? They're all there. Like when people see the word sine, cosine, tangent, secant, all those are ratios of the sides of a right triangle. So we have actually just identified all of them, but we're going to learn how to really pinpoint which one is the 4/5, which one is the 5/3, and learn how to identify those in the right triangle. So that's our goal. We're going to come back to this part, okay? So let's go briefly over the parts of a right triangle and the Pythagorean theorem. We're going to just really spend like a minute on this because I'm under the assumption that everybody in this class knows both of these things. But just to make sure I cover it, okay? So let's talk about the parts of a right triangle. We'll start with the easiest part, the part that's across from the right angle, always the longest line, which is the hypotenuse. Always the hypotenuse. Good, that's correct. What do we call the other two sides?
Legs.
They're called legs. Very good. This leg over here and this leg over here. So 2 legs and a hypotenuse make up a right triangle. All right, the Pythagorean theorem, of course, is this very basic one. Whoa, yikes. It says a squared plus b squared is equal to c squared. This relationship, that looks like a 3, doesn't it? This relationship among all the sides of a right triangle and the hypotenuse, the 2 legs and the hypotenuse. A squared plus b squared equals c squared. Raise your hand if you've seen that before. Let the record show everyone's hand is up. Good. Okay. Let's go on to number 2, the main idea of today. All right. The main idea of today is to understand where these trig functions come from and how to identify them, and then some symbols in between. Okay, so give yourself a right triangle up at the top there, A, B, and C. And also, please identify yourself the angle in which we will be referring to, theta. So I'm putting my angle down here. So that's important because I need to identify where my angles are. So I've got theta right there. All right. Name. Value slash name. Theta just represents an angle. Yeah, theta just represents an angle. Okay. Yeah. So now that I have identified, this is an important part, now that I have identified theta as being this angle on the lower right-hand side, what is the side that is opposite the angle called? What do we call that leg? The opposite leg. Yeah, I just told you, right? Good. What do we call the leg that is next to the angle in question? The adjacent. Good. No, that's down here. Adjacent. Of course, yeah. And then, of course, the other side, the other given, is just the hypotenuse, right? So, here we go. The first trig function we're going to talk about is the sine function. So, the sine of angle theta. The sine of angle theta, right? The abbreviation for sine of theta is just sin. Please do not call it sin. It's not a sin. It's not sin theta. It's sine theta. And the value is b, the ratio of b over c. Or we could also refer to it as the opposite side to the hypotenuse side. Okay, so the sine of theta is defined to be the opposite over the hypotenuse. Have you guys ever heard of SOHCAHTOA? Yeah. I could never remember it personally. I have a different one. I'll tell you what it is off the record. Okay. So there's the first one. And there's 6 of these, right? And these are the 6 basic functions that we're going to be working with all the rest of the year. The next one is called cosine. Cosine of theta. Now, does anyone know why the co is in front of the sine? And where that comes from? Little side note here. The co in front of cosine is meant complementary sine. So the complement to the sine. So it turns out that the sine of 30 degrees is the same thing as the complement sine of 60 degrees because 60 and 30 add to 90 and they make complementary angles. You guys know that? You did know that? Anybody else know that? 2 people knew that. Let the record show. So, the cosine is there. It's called complementary sine. And the abbreviation is COS, theta. But please do not call it cos. Please say cosine. And the definition of cosine is A over C, or the adjacent leg divided by the hypotenuse. So here's the COAH part in the SOHCAHTOA thing. All right, the next beautiful trig function is the tangent. Tangent of theta. The abbreviation for the tangent, of course, is just tan. Tan theta. Tangent theta. And the definition, the ratio of the opposite side, which is B, divided by the adjacent side, A. So the ratio of opposite to adjacent is defined to be tangent. So all of these trig functions they're nothing more than ratios. Tangent, okay? That was off the record. So now, there are 3 others, all right? There are 3 others, and the 3 others are just the reciprocals of the ones that we have here, okay? So we're talking about, the next one is cotangent. And the co still represents complementary tangent, cotangent. It's not the same thing as the -1. No, it's not. That means the angle whose tangent is. That's an inverse tangent, okay? That's not a same ratio. Okay, so the abbreviation for cotangent is COT, theta. Please do not say cot, okay? And its value is just A over B, the reciprocal of cotangent. So that would just be the adjacent divided by the opposite. So you might want to take note that these two are inverses, or they're reciprocals. That's the right way to say it. They're reciprocals. So let's talk about now the reciprocal to cosine, which is called secant. All right, so secant theta, the abbreviation is SEC theta. Please don't say sec. It's secant theta. And the rule is it's C over A, or the hypotenuse over the adjacent. Notice it's just the reciprocal of cosine. And the last one is called, the reciprocal to sine is cosecant. Oh, let's go back to blue here. Cosecant. Cosecant theta. And the abbreviation is CSC. Please don't say cosec. It is cosecant theta. And the abbreviation is, or the value is C over B, or hypotenuse over opposite. All right, that is all of them. That's all the 6 trig functions that we're going to be working with. And trig functions are nothing more than just ratios of sides of 4/5, right? Yeah, so we figured out that the 4/5 is the sine of theta, right? Which one is the 3/4? No. That's the cotangent of theta. Good. Which one is the 3/5? That's the cosine of theta. Very good. Which one is the 5/3? No. It's cosecant of theta. Very good. Which one is the 5/4? Wait a minute. Wait a minute. Yeah, this is cosecant. You guys. This one is cosecant. Which one's 5/3? There you go. Good. And then finally, 4/3 is? There we go. See? There they are. There they are. We found them. We just didn't know what their names were. Now we know what their names are, right? We can find and identify each one of them with respect to the angle that we're talking about, right? Because what's the sign if I tell you this angle is beta, what's the sign of beta?
3/4.
It'd be 3/4, right? They're different, right? So depending on the angle you're talking about. No, that wouldn't be 3/4. Sorry, it'd be 3/5. Thank you. Thank you. I was just going along with you. Okay, here we go. Here's an example. It is the third box here. Yeah, it's the third box. My 3 got erased. Okay. And what we're asked to do is find the value of all 6 of the trig functions, all right? And here's how I want you to set it up every single time. I want you to write up sine, cosine, and tangent in a row, just like that, right next to each other. And then below each of them, I want you to put their reciprocals. So below the tangent is the cotangent. That's the reciprocal. Below the cosine is the secant. That's the reciprocal. Below the sine is the cosecant. That's the reciprocal. There's a reason I want you to do that, to make your life a little easier as you. Let's. You guys all set up? So let's go through this. Let me run you through this problem, show you what the deal is, right? If we identify the angle, let's identify the sides that we have. Okay? What is this side compared to the angle? That's the adjacent side, correct? And then what is this side? So that means the other side has to be what? The opposite. Okay, now we don't know that one yet, but of course we're going to find it using Pythagorean theorem. Very simple. So of these 6 that I have here, I already have been given 2 of them, haven't I? Which of the first main 3, sine, cosine, or tangent, have I been given? No. I've been given cosine, haven't I? Because that's just 3.6 over 4.9, and then whatever that is, we can figure it out. Now, the cool thing about writing it in this way is that once you have the one on the top, you just take the reciprocal and you have the one on the bottom. So this should be 4.9 over 3.6. You don't even have to think about it. So it's important you set it up this way every single time. Sine, cosine, tangent on the top, cosecant, secant, cotangent on the bottom. Okay, now, so before we've done anything, we already have a third of our work done, right? So we need to figure out the opposite side. And how we're going to do that? We're going to use the Pythagorean theorem. So we're going to say 3.6 squared plus something squared is 4.9 squared. So you guys can bust that out. Tell me what it is. 6.1. No, it can't be. Hypotenuse is the longest. 3.3? Yeah. 3.3. Okay, we're going to go with 3.3. Okay, so now we know that one, right? So let's get the sine. What would the sine have to be of theta? 3.3 over 4.9. Now that means that the cosecant has to be 4.9 over 3.3, doesn't it? Yeah. Well, look, we're almost done. What's tangent? 3.3, opposite over adjacent. So over 3.6, right? Now take the reciprocal, 3.6 over 3.3. And there you go. Now the book, they may want you to actually go and figure out what this is, but of course we can easily do that, right? So that's the trick. The trick is setting it up in this way, sine, cosine, tangent, and then all the reciprocals below it, because then once you get one, you just bust out the second one right below it. So you don't have to do 6 individual problems. No picture, no nothing. Yes, I'm so glad some of you picked up on that. Yeah, if they just give us this little bit of information, right? Well, first we're always going to write down, okay, I know what's my sine theta, what's my cosine theta, what's my tangent of theta, what's my cotangent of theta, what is my secant of theta going to be, and then finally what's my cosecant of theta. So that's what we do first, right? We set those all up first. Then we can actually draw a triangle, because we do know some of the information. Here's a right angle, here's theta. And what do I know about theta? I know something, don't I? I know its sine has a ratio of 1 to 2. So where does the 1 have to go? It has to go across from the angle, because the sine is the opposite over the hypotenuse. And since the hypotenuse now, this is the opposite, this is the hypotenuse. Isn't that cool? Ah, very tricky, right? So where does the rad 3 have to go? The adjacent. There it is. And check it out. Rad 3, oh my gosh, over 2. Everything is consistent. It's all working out. So they may not give you a picture. They may just give you the sine of theta is something. You can then apply the information from that to the picture and get everything you need. So let's bust this out really quick here. Sine of theta is a half. So that means the cosecant is 2. Right? Isn't that nice? You have to think about it. So the cosine of theta is a rad 3 over 2. So the secant is 2 over rad 3. But of course, you can't leave it like that. So 2 rad 3 over 3 when you rationalize the denominator. Okay, the tangent is the opposite over the adjacent, so that is 1 over the square root of 3, but of course that's just rad 3 over 3 because you can't leave it like that. And then therefore the reciprocal of 1 over rad 3 for cotangent is just rad 3. And there you go. You have all 6 functions, and that takes like 30 seconds. What do you guys think? Good to go? Okay.